Hi everyone. In this lesson I'm going to be demonstrating how to solve this problem, and we're going to be making this a TeX active solution, so I'll be using my Casio graphing calculator. Now let's begin here, and we'll start off by looking at what we've got here. So we have a 30 by 40 centimeter sheet of metal. We're going to chop out the corners, so these pieces will be taken away, and then we'll be folding the edges up. So the base of the tin is going to be this red rectangle I'm drawing in, and then the edges would be folded upwards, something like this. There we go. Now the distance x here that we've chopped out of the corner, that would end up being the height of the tin. The length of the tin would be 40 centimeters with x subtracted from both ends, so taking away 2x, and the width of the tin likewise would be 30. Subtract 2x. Now we are supposed to discuss or explain how the volume changes as x changes. Effectively, they're asking us to think about how is volume depending on x, in other words, v as a function of x. Well, to find the volume, we would go length by width by height. So we would have 40 take 2x by 30 take 2x by the height of x. Now that's a perfectly good way to express the function. That's the function there is in factored form. That's okay. Now I think at this point I'm just going to get my calculator going, and we're going to have a look at what the graph of that function would look like. So let's use the graphing app, and we have to enter this, don't we? 40 take 2x, 30 take 2x multiplied by x. I'll draw that and see what we've got. Nothing terribly good. So I'm on the default view window here at the moment. That's not doing great. So let's just zoom out a little bit and see if we can see anything a bit better. Still not much good. I might try doing a zoom auto. So F5. The thing about zoom auto, it won't change the x-axis, but it will rescale the y-axis to see what's happening there. So let's do a zoom auto. Okay, we're starting to get somewhere. Now, I don't think any of this is useful information. This is where x is negative numbers. And of course, x represented a dimension, a distance that we were cutting from the corner of this. We can't chop negative distances. So I really should reset that to 0. And while we're thinking about x, the x could get bigger and bigger and bigger until the side of this cutout bumps into the side of this cutout, and that would happen when x equaled 15. So I think 15 would be a sensible upper limit for x, and I might make that go up in steps of 5. We'll exit from there and we'll draw that, and now I'll do the zoom auto once again. Now that's looking pretty good. So when x is 0, the volume is nothing. As x increases, the volume increases because we're starting to fold up taller edges. We get to a point somewhere here where the volume is maximum, and then as x increases even more, the edges get taller, but the base would be getting smaller, and so that must have a compensating effect where the volume decreases. Eventually, if x equaled 15, we would fold the thing up, there'd be no base left, so it would be 0 area for the base, it'd be 0 volume. So that's a good way to describe what's going on. We could do a small sketch. Here we go. There's volume. There's x. And the graph went upwards and it had a maximum point and then it started curving downwards. Now it would have gone below 0, but those are, sorry, I meant to put that as an open point. Those are pretty much what I would say. I would say that x has to be greater than 0, but less than 15. I wouldn't include those. And we need to find this maximum point, don't we? Up there. Again, we can do that with our calculator. So once this is on display, I might just scroll upwards a bit, somewhere there. I'll press the Gsolve key and then I'll press F2 for maximum. And there it is. My x value of 5.7 gives me 3,032 cubic centimeters. So that point up there, 5.7 for x, 3,032. So we've covered the domain, the value of x that produces the maximum. So we would say x equals 5.7 centimeters maximizes the volume. And we're done. Thanks for watching.